review for test 1 by Dennis Salinas. Question 1, first thing we want to find is the inverse of the function f of x. So we're going to begin with this. And this is the function f of x, so let's start finding that first. So right here, f of x is equal to x minus 3, everything to the second power. Okay. So the very first step to find an inverse function is going to be to change the f of x to y. Step number 2 is we need to interchange the x and the y variables. So that gives us x is equal to y minus 3 squared. And the third step of this process is going to be to solve for y. So to leave the y by itself, number one thing is that we need to get rid of that square by using the square root property. So we are going to do the square root on both sides, since the square root and the square are opposite operations. So square root and square cancels out, but remember the square root, we're gonna, according to the square root property, is going to be plus or minus. Now in this particular case, remember that the plus or minus the square root is going to create two shapes. It is going to create this one for the positive square root and this one for the negative square root. Okay. Right now when we look at the graph, but when we graph its inverse, you're gonna basically easily determine which one of those two is gonna be the correct function. Okay. So right now I am not going to put the plus or minus, so I'm just gonna put it right at the end once we graph this function. So I'm just gonna write it as the square root of x equals to y minus 3. Okay. So now we need to add the 3 to both sides to solve for y. So that gives us y is equal to square root of x, and then on the outside a plus 3. Okay. So then remember we need to change it back to f of x. That's what the y represents, but since this is the inverse function, an inverse is represented by the power of -1. That means the inverse of f of x is equal to the square root of x plus 3. And this is the first part of the question, and we are going to do the plus or minus at the end. I'm just going to leave that pending. Okay. So the next thing we're going to do is that we need to graph the function f of x and its inverse. So we're going to start by creating a table of values for the function f of x. And according to this function, it tells me that there's a restriction, that all of the values of x for this function must be greater than or equal to 3. And that happens because remember that a whole parabola, this x squared, the function x squared represents a parabola, but the parabola does not have an inverse that is a function, because if I draw the horizontal line test, the horizontal line intersects the graph in more than one point. So when I say, remember that this one tells you that the middle of the parabola is going to be located at 3, right here. So this basically is restricting the domain for any value of x that is greater than or equal to 3, so which is basically talking about the right half of this parabola. And if I just draw the right half, then that has an inverse function. That is actually a function, right? So that's basically what this consists of. So if x has to be any number greater than or equal to 3 on this function, then we can use the values 3, 4, 5, and 6, and 7, and so on and so on. So I'm just going to use those 3 values. Remember, the minimum we need is 3 points, right? So we're going to have x, which in this case is 3 minus 3 squared, gives me 0 squared, which is equal to 0. X, which is 4 minus 3 squared, equals to 1 squared, which is equal to 1. 5 minus 3 squared is going to be equal to 2 squared, which is equal to 4. So I'm just going to write down here for the function f of x, we got the following points: 3, 0, 4, 1, and 5, 4. So 3, 0 is located here, 4, 1, and 5, and 4, which is up here. So this graph represents the right side of the parabola, like I stated before. So it is a quadratic function, it is a parabola, but just the right side. So that's the function f of x. Now let's go ahead and graph its inverse. How do we graph its inverse? Very simple, right? So all we gotta do is we have to remember that we interchange the x and the y, so that means that the x and the y values for the function f of x will be interchanged, and that will create the inverse relation for that. So that would be 0, 3, 1, 4, and 4, 5. So we graph that. 0, 3 is going to be located here, 1, 4, which is here, and 4, 5, which is right here. And that creates its inverse. Remember that a function and its inverse must be a reflection of each other over the line y equals to x. So this is the line of reflection of the two graphs, and they, it moved a little bit, and if you notice, they create a reflection of each other. So if I reflect this inverse graph onto this line, it's going to create the black graph, which is f of x, and if I reflect the f of x graph onto this line, it's going to create the inverse graph, right? So this is the inverse of f of x. Now let's go back to the equation. Remember that I told you when we do the square root, it is a plus or a minus, right? But in this case, when the square root function, it is basically going up right here. It is like this half of a parabola that goes up. That is going to be the positive square root. So we're okay with the equation. I don't have to put the plus in the front. So we have understood that there's a plus in front of the square root, a positive. Okay? Okay, so we found the second part of the question. So we graphed the function f of x and its inverse function, which is this right here. Part C. Now we need to determine what is the domain and the range of both the function f of x and its inverse. That is the last part of this question. So I'm just going to start with f of x. I'm going to find the domain and its range. So let's look at f of x. And what we see is that the graph of f of x, if we look at the x-axis, the first value of x that we can detect is x equals to 3 on this function. And then what we can see is that the graph keeps on going, keeps on going, keeps on going, keeps on going. So which means that every value of x after 3 is going to have a point on the graph. So 6 is on the graph, 7 is on the graph, 8 is on the graph, and so on and so on and so on. So this graph is going to go all the way to the right to positive infinity. So it's going to contain all the values of x which are after or greater than 3, greater than or equal to 3. So in this case, if we want to write the domain, we're going to put it in interval notation as usual. So we're going to say that the domain is any number x that is from 3 inclusive, so which means bracket, comma, all the way to positive infinity. Now for the range, now we're going to look at the y values. Now the lowest point, it is located here again. So that means that the lowest y value, it is right here at the number 0. This is y equals 0 in the middle. And then the graph keeps going up, keeps going up, keeps going up, keeps going up. So every value greater than 0 will be on the graph. 7 is on the graph, 8 is on the graph, so that means it goes all the way to positive infinity on the y-axis. So my range for this function will be any number from 0 inclusive, so bracket, comma, all the way to positive infinity. Now, very simple now. Remember the definition of an inverse. It tells you that the domain of the function f of x will be the same as the range of its inverse function. So the range of the inverse will be from 3 to positive infinity, and the range of f of x will be the same as the domain of its inverse function, which will be from 0, comma, all the way to positive infinity. And these are the three parts for this question. Next. Now we are going to do the same here. So we are going to use, again, first of all, find the inverse of the function. That is the first question of this problem. Okay? So we're going to start with the function f of x equals the square root of x minus 2, right? So we already see that this function, it's already positive square root, which means that we're expecting the positive side of the square root, which is the upper half of the parabola going sideways. So that's what we expect as the graph. So we're going to, first of all, do the inverse, and the steps are, we're going to change f of x to a y. That's step number 1 here. So y equals to the square root of x minus 2. Then we are going to interchange the x and the y, so that gives me x equals to the square root of y minus 2. And then we have to solve for y. Now the first thing to solve for y is that we need to eliminate the square root from here, so we can get rid of that 2, right? Because the 2 is inside. So to get rid of the square root, the opposite operation would be the second power. So which means that if I need to raise both sides to the second power. The square root and the square just cancel out, so that just leaves me with the y minus 2 on the right side equals to x to the second power. Then to solve for y, we're going to add the 2 to the other side, so that gives me y is equal to x squared plus 2. And then we need to change the y back to f of x, which is the original name of the function, but since this equation represents the inverse, it's going to be with the power of -1, which means the inverse of f of x equals to x squared plus 2. Next part. Now we need to graph the function f of x and its inverse. So we're going to start with f of x as usual. So, to graph the function f of x, we're going to select the values of x that will give us a perfect square inside of the square root, right? We need to find values of x that give me a perfect square. So, for example, perfect squares are 0. So, the first perfect square is 0. What number, when I substitute it into the x right here, minus 2, is going to give me a 0 as an answer? Positive 2. Right, so that's my first value of x, because if I substitute it into the square root, that gives me square root of 2 minus 2, which is a square root of 0, and that is a perfect square, which equals to 0. I'm just going to try to avoid getting decimal solutions. That's why I'm trying to use perfect squares for the square root. The next one, the next perfect square is 1, right? So what number substituted into the x minus 2 is going to give me a 1? So it's going to be a 3. Right? So it's going to be the square root of 3 minus 2 gives me the square root of 1, which is 1. And that's a perfect square, right? Square root of 1 equals 1. Next one, the next perfect square is 4. So what number substituted into the x minus 2 is going to give me a 4? 6, right? 6. So if I substitute it, 6 minus 2 is going to be the square root of 4, and the square root of 4 is equal to 2. So I think that's more than enough, because remember we only require 3 points, right? So the function f of x has the points 2, 0, 3, 1, and 6, and 2. So we're going to graph the function f of x, which is 2, 0, 3, 1, and 6, 2. So that creates, remember, since it is a positive square root, the upper half of the sideways parabola, right? That's what it creates. So this is the function f of x. How do we get the graph of its inverse? We just interchange the x and the y values, right? So to get the inverse of f of x, the inverse will be Instead of 2, 0, it's going to be 0, comma 2. Instead of 3, 1, it's going to become 1, comma 3. And instead of 6, 2, it's going to become 2, comma 6. So if we graph that, it gives us this, 0, 2, 1, 3, and 2, comma, and 6. And this is the inverse function. And how do we check that it is the correct graph? Basically, do the line of reflection. Remember that the graph of f of x must be a reflection of the graph of f of x over the line y equals to x. You can see that the f of x is being reflected over this line to create the f to the negative 1 of x, which is its inverse, and the inverse, if I reflect it over the line y equals to x, is going to create f of x, right? So that was the second part of the question. We already did graph f of x and its inverse right here. And last but not least, third part of the question, we're going to determine the domain of both f of x and its inverse function. So we're going to start with f of x. The domain of f of x, remember that right here the f of x is this one. This is the first value of x that we see on the graph, the smallest one, and then it keeps on going, 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 which means that every value of x greater than 2 or equal to 2 is going to be on the graph. 8 is on the graph, 9 is on the graph, 10, so it goes all the way to positive infinity. So when we write the domain, we're going to say that it's going to start from 2, including the number 2, so with the bracket, comma, all the way to positive infinity. Range. Now if we look at the y values, this is the first point on the graph, and the y value for that, it is going to be 0. That's the y value right here in the middle. So that's the lowest y value on the graph, and then from there, what's happening? The graph keeps going up, keeps going up, keeps going up, keeps going up. So every y value greater than 0 is going to have a point on the graph. So 6 is on the graph, 7 is on the graph, 8 is on the graph. So it goes all the way up to positive infinity. So the range is going to be every value of x, y, including 0, all the way to positive infinity. Okay, so we're going to write it like this, bracket, 0, comma, infinity. Now, for its inverse function, remember that the definition of the inverse tells me that the domain of f of x will be the same as the range of the inverse of the function f of x. So the range will be from 2 to infinity of the inverse, and the range of the function f of x will be the same as the domain of the inverse function, which is going to be from 0 to infinity. And that completes this question. Next. Now we are going to do the same thing here. First thing that we got to do, of course, is we're going to find the inverse of the function f of x again. Okay, let's start with that. So f of x equals to the cube root of x plus 4. So f of x, first of all, remember the 4 steps are that we need to switch the f of x to a y. So y equals to the cube root of x plus 4. Then I have to switch the x and the y. That's the step number 2. Interchange x and y. So that gives me x equals to the cube root of y plus 4. And then we have to solve for y. Now in this one, we don't get the cube first, right? Because you see that there's a 4 on the outside, so we need to get rid of that 4 first. So that would be then step 1 here to get rid of, to solve for y. So we subtract the 4 to both sides. So that gives me x minus 4 equals to the cube root of y. And then remember that the opposite of the root is going to be the power. So this one is a cube root, so if I raise it to the third power, that's going to eliminate the cube root. But I have to raise both sides to the third power. So the cube root and the cube, they cancel out, so that leaves me with y. I'm going to put the y on the left side. equals to x minus 4, everything raised to the third power. So we're going to change the y back to f of x, but since this represents the inverse function, then we are going to raise it to the negative 1 power. This means the inverse of f of x is x minus 4 cubed. Second part of the question. Now what we need to do, we need to graph the function f of x and its inverse. So that's the next part of the question. Graph the function f of x and its inverse. Okay? So that's what we're going to do next. First of all, we're going to create a table for the function f of x as usual. And to make it more exact, for this kind of graphs, I usually like to use 5 points, but again, remember that you only need 3. But if I just do 3 in this particular case, you're gonna see that you're gonna think that it's gonna look like a line, which it doesn't. Okay, so I'm just gonna create an additional points as I usually do. In this particular case, since it is a cube root, remember that for square roots and cube roots we have to use special values. So I need to use values of x that will give me a perfect cubed inside of this root. Perfect cubes will be, for example, negative 2 cubed is negative 8. So I'm using that one because negative 8 will be the smallest one that fits in here basically. So right here, see? So also on this one, I'm just going to extend it a little bit. Okay, so negative 8, negative 2 cubed, which is negative 8. Okay, that's a perfect cubed. Negative 1 cubed, which is negative 1, that's a perfect cubed. 0 cubed, which is 0, so that's a perfect cubed. 1 cubed, which is 1, that's a perfect cubed. And 2 cubed, which is 8, so 8 is a perfect cube. So now if I substitute them, look, cube root of negative 8, cube root of negative 8 plus 4. The cube root of negative 8 is negative 2 because negative 2 cubed equals negative 8. But then plus 4 is going to give me a positive 2. Next one, cube root of negative 1 plus 4. The cube root of negative 1 is negative 1 because negative 1 cubed is negative 1, right? And then plus 4 is going to give me a 3. Cube root of 0 is going to be 0 plus 4 is going to give me a 4. Cube root of 1 is going to be 1, but then plus 4 is going to give me a 5. And the last one, cube root of 8, is a 2, but then plus 4 is going to give me a 6. So for f of x, I got the following points. Again, if you remember the shape of the cube root, 3 points will be more than sufficient, okay? But if you don't, then you might get into problems if you just do 3 points in this case, because it will not necessarily look like the shape that we're expecting if you just do 3. So negative 8 comma positive 2. The next one is negative 1 comma 3. The next one is 0 comma 4. The next one is 1 comma 5. And the last one is going to give me 8 comma and 6. Okay, so let's graph that function. Negative 8 comma negative 2 is down here. Negative 1 comma positive 3. Negative 1 comma positive 3. Let me see. Is right here. Okay. Let me see. Negative 1. Oh, positive 2. That's why. No wonder. No, so let me go back. Negative 8 comma positive 2. So it was looking weird. Negative 1 comma positive 3, which is right here. Then we got 0 comma positive 4. 1 comma positive 5, and the last one would be 8 comma and positive 6, which is up here. And this is the graph that we create for that function f of x. I'm just going to extend it from here. Hold on, let me make it more better for you so you can see. If I extend the graph, it's going to look like this. the graph of the cube root, it looks like basically like a cubic function, like an S shape, but going sideways from left to right. Right? It's a little bit different from the x cubed. So this is the function f of x, and then similarly, to graph the inverse of this function, all we have to do is interchange the x and the y values. So that is going to create the inverse of f of x, which is going to give me 2 comma negative 8, 3 comma negative 1, 4 comma and 0, 5 comma and 1, and 6 comma and 8. So we graph those points. Negative 2, negative 8 is going to be down here. Then negative 2 negative 8, I'm sorry, 2 negative 8 is going to be down here. It's positive 2 negative 8. 3 negative 1 is going to be here. Then the next one is going to be 4 0, which is here. Then it's 5 1, which is here. And the last one is 6 comma and 8, which is going to be up here. Okay, so if we connect it, this is the way the inverse is the inverse of this is going to look like. So let me kind of slant it to get from here. It's going to be a little bit slanted to get from here to here, and then it slants more, and then from here to here is going to go slanted a little bit, and then it keeps on going. Also, it keeps on going this way. Okay, if you draw this line y equals to x, we should clearly see that the function f of x is being reflected over this line to create the f to the negative 1 of x, which is the inverse. And if I reflect this inverse over the line y equals to x, it creates this function f of x. Okay, so that was the second part of the question. We graphed the function f of x and its inverse function. Last part of the question. Now what we want to do is we want to determine the domain and the range of the function f of x and its inverse function. So we're going to finish the question with that. Okay. So to get the domain, let's start with f of x. To get the domain of f of x, first thing that we can see is look at the smallest x value. Is negative 8 the smallest x value? Is negative 9 the smallest x value? Not really, right? Because this graph keeps on going all the way to the left side. So that means it's going to begin from negative infinity. It includes every negative value of x in its graph. But this one also keeps on going all the way to the right side. So it is going to include every value all the way to the right side. So then the domain is any number from negative infinity to positive infinity. It includes every value of x in its graph. So we're going to say from negative infinity all the way to positive infinity. The range, this graph is going down. So we cannot say that 2 is the smallest value on the graph. 1 is also going to be on the graph. 0 is going to be somewhere on the graph on the left side. Negative 1 is also going to be somewhere on the left side on the graph. So every negative value of y is on the graph. So it's going to begin from negative infinity. And then what you see right here is that this graph keeps going up, So 6 is going to be on the graph, 7 is on the graph, 8 is on the graph. So it also has every positive value of y on the graph. So that means my range is going to be any number from negative infinity all the way to positive infinity. Remember, according to the definition of an inverse, the domain of f of x will be the same as the range of its inverse function. So the range of the inverse will be from negative infinity to infinity, and the range of f of x will be the same as the domain of its inverse function, which will be from negative infinity to infinity. And that completes this question. Question number 4. Now, for the following problems, we want to perform the indicated operations, and we're going to write the result in standard form. Standard form of a complex, this is a complex number. Standard form of a complex number is the form a plus bi. So, The first thing that we gotta do is that we need to simplify that square root. Okay? Remembering that that square root of negative 12 is the same thing as the square root of negative 1 times the square root of 12. And the square root of negative 1, remember that makes it a non-real solution. The definition of the square root of negative 1 is I. Right? So that's basically what we get there. So I'm going to do that first. Negative 10 plus, and that becomes an I times the square root of 12. But now for the square root of 12, this is the next thing we have to do. Since the square root of 12 is not a perfect square, remember what we have to do? We have to factor it, to simplify it by factoring. And we have to think of what is a perfect square that multiplies to 12. The largest perfect square that multiplies to 12 would be 4, right? 4 is a perfect square and multiplies to 12, so it will be 4 times 3. Okay, and then we simplify it by separating it. So we get negative 10 plus I, and then times the square root of 4. This is a product rule. The square root of 4 times the square root of 3, according to the product rule, is equal to the square root of 4 times the square root of 3. And then I separate, and then I simplify it. The square root of 4 is going to be equal to 2, right? So we're going to have I times 2 times the square root of 3 divided by 2. But I times 2 times the square root of 3, we can just rewrite it as 2I times the square root of 3. Everything divided by 2, right? Now to write it in the form A plus BI, the next thing we have to do is we're going to divide both of them by the number 2. So negative 10 divided by 2 plus 2I square root of 3 divided by 2. So right here, negative 10 divided by 2 gives me negative 5 as an answer. And plus, then right here, 2I divided by 2, so it gives me I. The 2's cancel, so that gives me I times the square root of 3. And this is my answer in the form of A plus BI. Okay? Next problem. Now for this one we're going to do exactly the same thing. First of all, we already know what's going to happen with the square root of negative 180. So that is the same thing as the square root of negative 1 times the square root of 180. Remember that that negative inside is going to tell you that this is a non-real solution. The square root of negative 1 becomes I, right? So everything divided by 6. So that's going to be basically negative 18 minus I times the square root of 180, but the square root of 180 has to be simplified. So right here, there are 3 perfect squares that are factors of 180. So the ones that we can factor the 180 are the square root of 4, the square root of 9, and the square root of 36. Those are the only ones that actually are factors of 180. So which one are we supposed to use? Always keep in mind we have to factor using the largest possible factor. So this will be square root of 36 times 5 equals to 180. Now we're going to separate it, right? We're going to factor it. So the property says that the square root of 36 times 5 is going to be the same thing as, according to the product rule, square root of 36 times the square root of 5. Right? And then we simplify this. The square root of 36 is going to be 6, right? So we get I times 6 times the square root of 5 divided by 6. But if I simplify that, I times 6 times the square root of 5, it is just the same thing as 6I times the square root of 5 divided by 6. Okay? Last part is, if I want to write the result in the standard form, which is the form A plus BI, what I have to do is divide them both by 6. So negative 18 divided by 6 right here, minus 6i square root of 5 divided by 6. So again, negative 18 divided by 6 gives me a negative 3, and minus 6i, 6i square root of 5 divided by 6. 6i divided by 6 cancels out the 6's, so that gives me I times the square root of 5. 6 and 6 simplify to 1, so that gives me I square root of 5. And so forth. We got the solution for this in the form a plus bi would be negative 3 minus I square root of 5. Question number 6. Now we're going to get into the topic of factoring. So to factor, we are going to do the following. We have to first of all remember the process on factoring. To factor a polynomial completely is that the first step of this is going to be that we need to see if the whole problem has a greatest common factor that can be factored out. So if we look at all of these terms, can I first of all, let's say, divide any x out of them? We cannot, because the last term does not have x, right? So the x is not a common factor. Can I divide any number, and is there any common value that can be divided out of 3, 6, 8, and 16? The answer is also no, right? So that means there is no greatest common factor on this problem to begin with. Second part of the question is, second part of the procedure is that now we need to determine what is the correct process for us to use to factor this polynomial. Since this polynomial has 1, 2, 3, 4 terms, okay? Since that polynomial has 4 terms, remember that the process we use when it has 4 terms is we factor by grouping. So we're going to start by doing this. 3x cubed minus 6x squared. I'm going to group these two terms. And also plus 8x minus 16. I'm going to group these two terms as well. I need to find the greatest common factor of each one of those groups. So the greatest common factor of these two, both of them we can factor x's. We can factor an x squared because that's the smallest exponent. And also we can divide them by 3, so the greatest common factor is 3x squared. So we're going to factor the 3x squared, and then we can do it as trying to find a number that multiplies times this, that gives me each one of these values to find out what's left inside of these parentheses, or simply just divide the 3x squared from these two terms. That's basically what we would have to do. 3x cubed divided by 3x squared is x, or in other words, or 3x squared times x equals to 3x cubed, right? Negative 6x squared divided by 3x squared is negative 2, or you can say 3x squared times what gives me negative 6x squared is negative 2. Now, from the other two terms, we can, from 8 and 16, we cannot factor an x because the 16 does not have an x. So we can divide 8 and 16 by a maximum value of 8. So I'm going to put the plus 8 right here on the outside of this parentheses. And you can say 8 times what equals to 8x. That will be x. 8 times what equals to negative 16. That will be negative 2. Or simply just divide them by 8. And you will find out what is left inside of that parentheses. Okay. Now, what else can we see? That once again, these two terms have a greatest common factor of x minus 2. So that means that we can factor out that x minus 2 from these two terms. So if I factor it out, what are we left with in the other parentheses? The 3x squared that is in front of that x minus 2, and the plus 8 that is in front of that x minus 2. So all we did is we factored the x minus 2's. Okay. Step number 3. There's a third step to this process. Can we factor this polynomial any further? Well, we determine that by looking at whether there's still a factor that contains squares. In this case, there is still a factor that contains squares. We have the second parenthesis. But remember there's only three formulas to be able to factor further. The three formulas are difference of two squares, sum of two cubes, and difference of two cubes. Because of the sign in the middle, the only possible formula that we could possibly use is this one. But the question is this: can I rewrite this equation as a number to the third power and this part of this expression as a number to the third power? The second part, yes, because 2 to the third power is 8, but can I find a number that when I cube it equals to 3? The answer is no, right? So that means that we cannot actually use that formula, and thus that second parenthesis cannot be factored any further. So that's it. So none of these can actually be used. This is my final answer for this question. Question number 7. We are going to do the same thing here. So the first part of the procedure is number 1. We need to find out if there is a greatest common factor that can be factored out from all of these terms to begin with. Can I factor an x, any x's from these 4 terms? The answer is no, because the last term does not have any x's, right? Can I factor or divide these 4 values, these 4 numbers by any number? No, because the only divisor of 1 is going to be the number 1. 1 can only be divided by 1, right? So what do we say here to begin with? We don't have any GCF in common, right? There's no GCF. So step number 2, we need to determine what is the correct process to use in this to factor this expression. And once again, since this polynomial has 1, 2, 3, 4 terms, to factor a polynomial with 4 terms, we use the process called grouping. So we're going to start doing the grouping right here. So we got x cubed minus 4x squared. We're going to group the first 2 terms here. Then we got minus 36x plus 144. And we're going to group these 2 terms also. Okay. So the first 2 terms, what can we factor out? Both of them have x's, so we can factor 2 x's, right? The smallest exponent is x squared, so we can factor x squared. And the numbers are 1 and 4, so we cannot divide anything from 1 and 4, right? So just the x squared. So we're going to factor the x squared, and then we have to say, okay, so x squared times what gives me x to the third power? X. X squared times what gives me negative 4x squared? Well, negative 4. Or simply, just divide the x squared from these 2 terms. X cubed divided by x squared is x. Negative 4x squared divided by x squared is negative 4. Second parenthesis. Now, the greatest common factor. We know that since it has a negative here in the front, we're gonna whatever we're gonna factor has to be negative. So between 36 and 144, both of them can be divided by, well, by several values. They can be divided by 4, by 9, but also by 36. Okay, so the largest one is 36. That's the greatest common factor. So we're going to factor a 36 from both of them. And then we think of we need to think of what number multiplies times negative 36 right here to give me negative 36x, x. What number times negative 36 right here is going to give me 144? Negative 4. Negative times negative is positive. Or simply, just divide both of these numbers by negative 36 and you're going to get the same thing. Negative 36x divided by negative 36 is x, and 144 divided by negative 36 is negative 4. Next. Now, you see that on these 2 factors, we ended up with another greatest common factor. So now these 2 terms have a greatest common factor of x minus 4. So what I am going to do, I am going to factor again that x minus 4. And if I factor the x minus 4 from those 2 terms, they disappear, and that leaves me with x squared minus 36. We just factor that out. Okay? So we finished the grouping part. Now, step number 3. Question is, can we factor further? Well, in this polynomial, since we still have a square right here, right? So we might be able to factor further. So how do we know if we can? Well, for any polynomial with 2 terms, just like the previous question, we have something similar. There's only 3 possible formulas: a squared minus b squared, a cubed plus b cubed, and a cubed minus b cubed. So right here, this one either looks like this, like the first one, or like the third one because it has a minus in the middle. Let's see if we can write them as squares to begin with. That's what the first formula tells me. I need to find something that's square. In order for it to be the first formula, which is difference of squares, I need to find something that square gives me x squared, which in this case is x times x, is x squared, right? So that would be x. And I need to find out something that square gives me 36, which in this case, there's a number, 6 times 6 equals to 36, or 6 squared equals 36. So automatically, this one basically can be factored using the first formula. All of this can be factored using that, because that's what we see. A squared minus b squared equals to a plus b times a minus b. Those are the factors into parentheses. So right here, we already know what a and b is. A is x and b is 6. This is a squared minus b squared. So since a is x and b is 6, we factor it into a plus b, which is x plus 6, and a minus b, which is x minus 6. And we just bring down the factor that we had in the front, which is x minus 4. Can we factor any further? The answer is no, because all of these factors are linear. They have x, x, and x. So we have completed this factoring process. Question number 8. For the following problem, again, we're going to factor completely or state that the polynomial is prime. So we're going to start with the same process right here. Now, we're going to first of all find out if this polynomial has a greatest common factor that can be factored out from all of these terms. 81x squared, 18x and 1. Can I factor any x's? No, because the last term does not have x. Can I divide the 3 numbers by any number? No, because 1 can only be divided by 1, right? So what does that mean? That there is no greatest common factor on this problem. Second part in the process. There are 2 ways that we can approach this, okay? Because this is going to be a special trinomial. We call it a trinomial because it has 3 terms, right? So for trinomials, the main method that we usually use is called the AC method. That's exactly what I'm going to use, the AC method. And how does the AC method works? Basically, we're going to multiply a, which is 81, the number in front of the x squared, times c, which is the constant. 81 times 1 gives me 81. Then what do we need to do? Find 2 numbers that multiply to 81, and this sign tells me that when I add them, they give me positive 18 as an answer. So 1 times 81, do those work? No, because 81 plus 1 is not 18, right? And then the next one is 3 times 27. Does 27 plus 3 add up to 18? No, right? And the next one would be 9 times 9. 9 plus 9, that adds up to 18, right? So those are the correct factors. So if we do this, this is what we're going to get. So we're going to have the x squared. So we're going to put it into x and x. Then the 81 is going to be a 9 and a 9, right? So then, since this one is, they both, in order for we to get positive 18, both of them must be positive. Last step of the AC method is that we need to divide both of these factors by the A, which in this case is 81. But in this case, we cannot divide the 9 by 81, but what can we do? We can simplify both fractions. We can divide the 9 and the 81 by a 9, and we can do the same thing here, divide the 9 and the 81 by a 9. And that leaves us with x plus 9 divided by 9, which is 1, over 81 divided by 9, which is 9. Same thing with the second parenthesis, 1, 9. What do we do to finish this process? The denominator of this fraction, we're going to put it in front of the x, and that's going to be the same case for that one. So my two factors will be 9x plus 1 times 9x plus 1, but since we got the same factor repeated, we can write it like this. Since it is the same thing twice, 9x plus 1 squared. And you see that both of these factors are linear. Both of them have x and x, right? So can I actually say that I can factor further? Not really, right? In this case, it is understood that we cannot factor any further because we have x and x on both factors. There is no squares on these factors. They're linear, both. Okay? So there is a second process that we can use. Is that one is called a perfect square trinomial, and there is a formula that was there in the lecture, but again, I told you that again it is recommended that we actually use the AC method because we're not going to see this very often. Okay, so most of the trinomials that we're going to do, of course, they cannot be factored using the formula. So I'm just going to stick to the AC method. Okay. Next question. Question 9. For the following problem, we're going to factor completely or state that the polynomial is prime. So once again, step number 1, we have to find out if this polynomial has a greatest common factor. So what do? We have to see if all of these, first of all, let's think about if they can all be divided by x. Can I divide an x from all of them? No, because the last term does not have an x. Correct? Can I divide any number from 7, 67, and 36? No, because 7 can only be divided by 1 and 7, and the rest of them cannot be divided by 7, right? So right here we say that, once again, there's nothing that can be factored, so we have no greatest common factor. Then, to factor the trinomial, we're going to follow the same rule. This is a 3-term polynomial, 1, 2, and 3. Right, so that's a trinomial. So we're going to use again the AC method because it's a trinomial. So to factor the trinomial, again we are going to multiply A times C. Right here, A is 7, the number in front of the x squared, and C, which is the constant, is 36. That's what we get for that one. Okay, so that's what we're going to get there. So that gives us 252. So we need to find out two numbers that multiply to 252 and at the same time they add up to 67 or negative 67. Well, we'll put the signs in a bit. I'm not going to work with the signs yet, just 67. So 1 times 252. 252 plus 1 is not equal to 67, so these are not the factors. 2 times 126 multiplies to 252, but 126 plus 2 is not equal to 67 either. 3 times 84, 84 times 3 is 252, but 84 plus 3 is not equal to 67. The next one, we can also factor it by 4. 4 times 63 is equal to 252, and what do you see here? 63 and 4 add up to 67. So those are the correct factors. We can open the parentheses, and we have the factors 4 and 63, and the x squared is x and x, right? So we factor that x squared into x and x. Then the sign, since it is a negative 67, both of them must be negative. Negative 4 plus negative 63 equals negative 67. Last step in the process of the AC method is that we need to divide both of these factors by A. In this case, A is 7, so I divide them by 7. 4 divided by 7, you cannot divide it, but again, can I simplify this fraction? That's the question. Can I simplify it? No, right? 4 and 7 cannot be simplified, so what do? Then we're going to bring the 7 in front of the x. So that would give me a 7x minus 4. And 63 divided by 7 is going to be x minus a 9. And the question, part number 3, can I factor this any further? The answer would be no, because both of the factors have x and x. They're linear factors. We don't have any squares or any exponents on these factors, so that means this is my final factor, the final factorization of this, the complete factorization of this trinomial. Next question. Now we're going to get into composite functions. So on this one, we're going to start by remembering what the g of f of x basically means. G of f of x means that we are going to substitute the function f into every x of the function g. So it's basically, this is what we're doing, right? We are going to substitute the function f into every x of the function g. In other words, the function f of x, which is 4x squared plus 2x plus 8, is going to be replaced into this x of the function g. So my function is going to look like 2 times x minus 4, but the x is going to become the function f, which is 4x squared plus 2x plus 8. Now, since this function, we don't have any x on any denominator x, right? And we don't have any x inside of a square root, which are the only two situations in which we had a domain restrictions in the domain. So that means that this graph or this equation f of x that we replaced in here automatically has a domain of negative infinity to positive infinity. So I'm going to point out to that because that's something we have to find. Okay, so that one, the domain of that part is from negative infinity to positive infinity. So that's the domain of that one. Now, let's finish this up by distributing, or we're going to simplify this function g of f of x so we can finish this. So we're going to distribute the 2 over to these three terms. 2 times 4x squared is 8x to the second power. 2 times 2x is going to be 4x. And 2 times 8 is going to be a positive 16. Then we're going to have a minus 4. Okay, then to finish this problem, we're going to combine the like terms right here. So the like terms will be these last two. So we're going to have 8x to the second power plus 4x plus 12. And now if you look at this final function that we obtained, that final function, it does not contain any x on the denominator, right? And does not contain x inside of a square root, which are the only exceptions, the only functions that have exceptions in the domain or exclusions in the domain. So that means also that this function has a domain of negative infinity to positive infinity. That's how we find the domain of a composite function. We have to find the domain of the function that is being substituted into the other function, which is in this case the domain of f of x, and we need to find the domain of the function that we composed, which is g of f of x, this final function. But both of these functions have a domain of negative to positive infinity, so that is the domain of the composite function g of f of x. Next, now we are going to do the same thing on question 11, but on this one the question says that we are going to find f of g of x. What does it mean by this? F of g of x means that we are going to substitute the function g into the function f of x. So we're going to substitute the function g in every x of the function f of x. This function g is going to be replaced into the x right here of the function f of x. So that's what x is going to become, 8 over x. So my function is going, my f of g of x is going to look like this function, 8 over x plus 8, but that x is going to be replaced with the function g, which is 8 over x. Okay, and now right away, let's find the domain before we complete this process. For the domain, remember that we need to find the domain of the function that we're substituting. So in this case, we're substituting the g. So right here, for the domain, we can see that that contains x on the denominator, and for that type of situations, we need to exclude anything that causes that denominator, which is x, to be equal to 0. The denominator cannot be equal to 0. And since this one is already x by itself, then that's already my solution. X cannot be equal to 0. That will be the value that basically we cannot substitute into the x of this function because it will make this fraction on the bottom undefined. Now, how do we simplify? That's the next thing. Now to finish this problem right here, how do we simplify this fraction that has a double fraction? It is a very simple process. All we have to do is we need to multiply the least common denominator, which in this case there's only one denominator here, x. Well, x and 1, because this is over 1 and this is over 1. But we don't have to include the 1 as my denominator. So my least common denominator, we're just going to say is x. So what I have to do is just multiply every term on this equation, on this function by the x. I need to multiply this by x, and that by x. So I multiply the x to this one, the x to this one, and the x to that one. Okay. So if I do that, we're going to end up with 8 times x, which is 8x, over 8x divided by x. The x's just cancel out, so that leaves me with the number 8 plus 8 times x, which is 8x. But now, what else can we see? That all of these terms can be simplified, because as we notice, the 8, the 8, and the 8, of course, they can all be divided by 8. Sometimes it is not possible, so in order for you to be able to simplify, all of these terms must be able to be divided by the same value. In this case, we can, so we're going to divide everything by 8, and that gives me x over 1 plus x. But wait a minute. We ended up with, this is the final function, so we already finished with this. This is the function f of g of x, but for the domain, this function has x on the denominator. So that means that that function also has a restriction. We need to exclude anything that causes that denominator to be equal to 0. So 1 plus x, which is the denominator of this fraction, cannot be equal to 0. So if I solve for x, we're going to see that x cannot be equal to -1. These are the only two values that the graph of this function f of g of x is not going to include. So if you want to write it in interval notation, you would say that the domain contains any value from -infinity, comma, and then it stops at -1, or, which means union, and then it continues from -1 and it stops at 0, or, and then it continues after 0, and then it keeps going to positive infinity. This is the domain, of course, in interval notation. If you write the domain in set notation, which again, we don't use it very much, but sometimes we use it, the domain in set notation, remember there's only 3 symbols that we can use for the set notation. greater than, less than, or not equal to. In this case, we're using the not equal to symbol right here. So we're going to write it as the set of all x such that x does not include or x is not equal to -1 or 0. That would be the domain in set notation. So either of these notations is correct, but of course the one that we're using the most is interval notation. Next question. For this function, we're going to graph the piecewise function f of x equals. It is a function consisting of two equations, x squared, but x squared will only contain any value of x. It says right here greater than -2, but at the same time less than or equal to 3. So basically it's going to contain any value greater than between -2 and +3, including 3, but not including 2. So keep in mind that this number is not included in the graph of this function. So when we create the table for this function, I'm going to start with that parabola f of x equals x squared. And of course, the first thing we're going to do is that we're going to select all of the possible values of x that can be used for that parabola. It tells me that it consists of any value greater than -2, so it would be -1, 0, 1, but less than or equal to 3, so it's going to go all the way to +3, so it's only that little section inside. Okay, so I'm going to just use the values, of course -2, but remember that -2 is not included. Okay, -1, 0, 1, 2, and all the way to +3, and +3 is included, right? So that's what we know on that one. So x squared, that's the function, that's how we're gonna get the value of y. So that would be x, which is -2 squared, gives me a +4. -1 squared gives me a +1. 0 squared gives me a 0. 1 squared gives me a 1, and 2 squared gives me a 4, and the last one, 3 squared, gives me a 9. So let's graph that piece of a parabola. -2, 4 is the first point, but what did we say about -2 on that graph? It says that it's not included, and not included on the graph is going to be represented by an open circle. Open circle means that that point is not included in the graph of that equation, of that piece of the function. Next one is -1, 1, then 0, 0, 1, 1, 2, 4, and 3, and 9. And 3 is included, so that one is a closed circle. So this is a parabola that is just going to extend from -2 right here all the way to +3 right here. Second piece of the function. Now the second piece of the function is we're going to create another small table right here, and that table is going to be for the function f of x equals to x. That's the second function we see there. But be careful here, x only contains the values of x greater than 3. So basically it's going to contain 4, 5, 6, 7, or any number greater than 3. Decimals as well, right? Any number greater than 3. So when I create the table, of course we're going to start from the middle value, which is 3, but keep in mind that that one, it says greater than 3, so the 3 is not included in this graph, right? And then it goes to 4, then it goes to 5, and so on, and so on, and so on. Right? I'm just going to do a few points because it's going to keep on going to the right, so I'm not going to do them all. So when x is equal to 3, y is equal to, since the function is f of x equals x, so when x is 3, y is also 3, because it's just x. The y is also equals to x. When x is 4, y is also 4. When x is 5, y is also 5, and so on and so on and so on. So this one we're going to have the point 3, 3, but we said that the 3 is not included, so it's an open circle. 4 comma 4, which is here, 5 comma 5, which is here, 6 comma 6, keeps on going, keeps on going, keeps on going. So this graph is going to keep extending from here all the way to the right side. And this is the whole function, the whole piecewise function, f of x. That's what it represents. Next, now we are going to do the following. Given the piecewise function f of x equals to 3x plus 6 for x less than or equal to 0, 6 minus 3x for x between 0 and 3. Remember, this means that x is a number between 0 and 3, and the function f of x equals x for any value of x that is greater than or equal to 3. So right here, what they want us to do is all we have to do is find the function value f of 4, which means find the value of y when x is equal to 4. Remember, just like we did on the previous question, only one of those pieces of the function is going to contain any given value. Oh, wait. Only one of those pieces of the function is going to contain any given value. Right here, we need to find out which one of those functions contains x equals to 4 in its domain. Remember that this part right here is the domain of each one of those functions, this right here. So the first function tells me that equation contains any value of x that is less than or equal to 0. So some examples would be 0, -1, -2, -3, -4, and so on and so on and so on. All the negative values, right? This function tells me that it is including only any number between 0 and 3. So that means that 1 and 2, those are the only wholes, but you can also have 2.5 or 1.5 or 0.5 or any other decimal, right? As long as it is between 0 and 3, right? So there's several. And the last function, it tells me that it includes any number of any number x that is greater than or equal to 3. So that graph of that function, that last function, is going to contain the numbers 3, of course, because it says equal to 3. 4 is going to contain 5, is going to contain 6, and so on and so on and so on. So 4 is on which one of those three equations? It is on the third equation, right? So that means that if I want to find the value of f of 4, I need to use this piece of a function f of x equals to x, because 4 is on that equation. So we're going to use the function f of x equals to x, that piece of the function. And if I want to find the value of x when x is equal to 4, all I do is I substitute the x with the 4 right here and right here. So f of 4 is going to be equal to 4. So which means that the value of y when x is 4 is going to be also 4. Next question. Now we are going to work on transformations of functions. Okay, so on the transformations of the functions, let's keep in mind what we have to do. So first of all, we're going to start by graphing the function f of x, and then we're going to use transformations of that function to create the function h of x right here. Okay, this is a little bit wrong right here, so let me correct it. So that's h of x right here. Okay, so we're going to start by, of course, graphing the function f of x as usual. I'm going to say f of x consists of the function square root of x. So for the square root, remember that we have to use some specific values of x. We have to use numbers that will produce a perfect square inside of the square root so that we can avoid decimals. So the number that I can substitute there is 0, because the square root of 0 equals to 0, right? That's a perfect square. Then we can use 1. because the square root of 1 is going to be equal to 1. Can I use 2? No, that is not a perfect square, right? That's going to give me a decimal. So the next one is 4, because the square root of 4 is going to give me a 2. And then I can use 9 also, because the square root of 9 is going to give me a 3 as an answer. So the function f of x consists of the points, f of x equals to x squared, consists of the points 0, 0, 1, 1, 4, 2, and 9, and 3. Okay. Next. Now we are going to use transformations to create the function h of x. Okay. So that function h of x. So first transformation that we must always do in the order is that we need to do the horizontal translation or horizontal shift. And the horizontal shift is always going to happen whenever we have a number that is being added or subtracted inside of the function to the x. Okay? So in this case, that plus 2, if you remember, if you recall, is going to make the function shift to the left 2 units. Remember, it changes the sign to the left 2 units, so it becomes a negative 2. So what is the only thing that will be affected in these points if I shift the function to the left 2 units? It is going to be that every x value is going to be subtracted by 2. So if I subtract the x values by 2, 0 minus 2 gives me negative 2, 0. 1 minus 2 gives me negative 1, 1. 4 minus 2 gives me 2, and then 2. And 9 minus 2 gives me a 7, 3. So that is the first transformation here. The second transformation. Now remember that the vertical shift, it is always the last transformation. So this has to be the last transformation that we are going to use. That is my last transformation, and like we said, this one is going to be my first transformation. Okay? So the next transformation in the order, it has to be the negative inside of the square root. That's the next transformation we are going to apply. So we already did the x plus 2, now we're going to do that negative. What does that negative on the x causes the function to do? It is going to reflect the graph over the y-axis. So what is going to happen if I reflect the graph over the y-axis? Well, two things. You can say that all of the x values will be multiplied times a negative, or that is the same thing as saying that all of the x values will change their signs. Okay. So if I change the signs of those x values, then we are going to get positive 2, 0, positive 1, 1, negative 2, 2, and negative 7, 3. So we just changed the signs of the x values. And last but not least, it is going to be the minus 1 at the end. So that is my last transformation. So we already did the negative x, square root of negative x plus 2. The last thing to create the function h of x will be that we need to do the minus 1. And that minus 1, remember what it happens, what it does on the function, it shifts the graph down 1 unit. And what is the only thing that will be affected in this point if I shift the graph down 1 unit? The y values will be subtracted by 1. So that is going to create the points 2, negative 1, 1, 0, negative 2, 1, and negative 7, positive 2. And this is the function that we are trying to graph, which is the function h of x. So we're going to graph. Oh, by the way, on your graph, we're going to display two functions. The function f of x that we created first. So I'm going to start by graphing the f of x, which is 0, 0, 1, 1, 4, 2, 9, 3. That is the function f of x right here. And it is half of a parabola going to the sides. Remember, that's what the square root of x looks like. And the second function is the h of x, which is 2, negative 1 right here, 1, 0, which is here, then negative 2, 1, negative 2, 1 is right here, and the last point is negative 7, comma, and positive 2. So remember that it was reflected over the y-axis, so it's going now to this side, right? This is what the graph looks like right now. It is going to this side. And this is my function h of x. So if I, for example, like we said, shift this function to the left 2 units, it's going to be here. Then we reflect it across the y-axis, then it's going to be here. And then when we shift it down 1 unit, it is going to create h of x. So, to finish this problem, now we need to describe how the graphs are related, okay? So make sure you use complete sentences. Now, if you use the words that of course the definitions use, it is going to be very simple to do. All we have to say is this: the graph of g of x. Well, not g of x. This one is h of x, correct? So we're going to say the graph of h of x is the graph of f of x, but first thing that happened is that it was shifted 2 units to the left, comma. Second transformation was that it was reflected over the y-axis, comma, and finally, I'm going to say and, shifted down or shifted 1 unit down or downward. And this is basically the whole description of how the graph of G is related to the graph of F. Exactly in the order in which it happens. Alright, so next problem. Now we are going to do the same thing with this one. It says that we are going to begin by graphing the function f of x equals to x squared, and then we're going to use transformations to create the graph of the function h of x equals x minus 3 squared plus 4. So let's start with the function f of x equals to x squared. So we're going to create a little table for that function f of x equals to x squared. So the first thing is that we are going to use the common values. Now this one is not a square root or a cube root, so we can use the values that you were taught in the section, which is in the section 2.1, which is -2, -1, 0, 1, and +2. But remember that you only need 3 values. So as long as you know the shape of the function, you can just use the middle 3 or any 3 values from here, but if you're not sure with the shape, then recommended for you to do the 5 points so you can see the shape more clearly. So this one is x squared, which is -2 to the second power. That's going to give us a 4. -1 squared give us a +1. 0 squared give us 0. 1 squared give us 1. And 2 squared give us a 4. So the function f of x, it is going to consist of the points -2, 4, -1, 1, 0, 0, 1, 1, and finally comma, and 4. Okay? So this creates the function f of x equals to x squared. Now, first transformation. Remember that the number inside of the parentheses always has to be my first transformation because that is my horizontal shift. And the number on the outside right here has to be my last transformation because that creates my vertical shift. Right? So in the order in which it happens, we're going to first of all do the x minus 3 inside of the parentheses. That minus 3, remember what change does it do? It makes the graph shift to the right 3 units. What is the only thing that will be affected in the points of this function f of x? Is that all of the x values will be added by 3 units. If it goes to the right, that means you're adding that number of units to the x's. Alright, so if we do that, then that's going to give us 1, 4. Then this is going to give us a 2, 1. 0 plus 3 gives us a 3, 0. 1 plus 3 is a 4, 1. And 2 plus 3 is a 5, 4. Now, next transformation is, now we're going to apply the plus 4. That's going to be the next thing. But that's basically going to complete the function, right? That plus 4, because this is going to be the function h of x already. So what is that plus 4 going to do to the function? It is going to shift it up 4 units. And when it shifts up 4 units, all of the y values will be added 4. And that gives us the following points. 1, 8. 2, 5. 3, 4. 4, 5. And 5, 8. And basically that is the function h of x. So that completes this question right here. All we gotta do, we're gonna graph both functions, f of x and h of x again. F of x, it is the original point we got right here, which is negative 2, 4. This is my f of x. Negative 1, 1. 0, 0. 1, 1. And 2, and 4. So if we connect these points, that's going to create a U shape or a parabola, right? That's the graph of the x squared, right? That opens up in both directions. This is what we're going to get right here, right? So that completes the function f of x, and h of x has the point 1, 8, which is here. Then 2, 5. 2, 5, which is right here. Then 3, 4, which is here. Then 4, 5, right here. And the last point is 5, 8, right in here. And this is the parabola for the function h of x. And that completes the question. Of course, I forgot to mention something, I believe. Let me go back really quick. Did I describe? Yes, I need to describe how the graph of G is related to the graph of F in this question, right? So that's what we need to do. So I'm going to write the description here. So there's only two things that we need to describe here, right? Because there's only two changes. So we're going to say that the graph of G of X is the graph of f of x, but the first thing that happened was that it was shifted to the right? So we're going to say shifted 3 units to the right. And the last transformation was that it was shifted 4 units up or upward. And this will be my description for those two graphs. Next question. Question 16, we are going to basically do the same thing. We're going to use the graph of f of x to create the graph of g of x. Now on this problem, the graph of f of x is already given. As you can see, the graph of f of x is the graph that we see on this picture. So we don't really need to create any graph. We don't really need to graph any points. The graph is already here. So we're just going to get the points from the graph of f of x, which we can actually, there's 5 points that we can see exactly on an integer. -4 is on an integer, -2, 0, 2, and 4. The other ones are decimals, right? So we're going to use those as a basis. So the function f of x has the points -4, +4, -2, +1, 0, 0, 2, 1, 4, 4. So remember that the first transformation must always be the horizontal shift, so that we can get it from the number right here inside. And the last transformation must be my vertical shift, which is this one. This should be my last transformation. So we're going to start with the +2. That's the first transformation that we have to do. And that +2, inside of that parenthesis, what effect is it going to have on the graph is that it's going to shift the graph to the left 2 units. If the graph is shifted to the left 2 units, what is going to be the change on these points is that every x value will be subtracted by 2. Every x value will be subtracted by 2. So if I do that, so if I subtract every x value by 2, then we're going to get the following points, which is -6, +4, -4, -1, -2, 0, 0, 1, and 2, 4. So, second change that we must apply is the negative, because the +1 should be my last transformation. So the negative in front of the f. So we're going to do negative f of x plus 2. Remember, when there's a negative on the outside of the function, that negative is going to cause the function to reflect over the x-axis. And what change is that going to cause to my point is going to change the signs or multiply all of the y values times a negative. That's basically what that is going to do. Multiply all of the y values times a negative, or change the signs of all of the y values. I'm just going to say, to make it simpler, let's just go ahead and change the signs of those y values. So my new points will be the following. -6, -4. -4, 1 changes to -1. -2, 0 stays the same, of course. 0, 1 changes to -1, and 2, 4 changes to -4. Now the last change that we need to apply is we already did the negative f of x plus 2. Now we need to do the +1, which means that the graph is going to be shifted up 1 unit, and this is going to finish the problem. This is going to create the function g of x, right? So what change is that going to have on my points right here? when I shift it up 1 unit, all of the y values will be added 1 unit. So if I add the 1 to the y values, then we're going to get -6, comma, -3, -4, comma, 0, right? -2, comma, 1, 0, comma, 0, and 2, comma, -3. So this creates the graph of the function g of x, which is basically what we wanted. This is going to be the end. So we're going to graph. Now we already have the graph of f of x here, so we don't need to create that graph. That graph is already given, right? The only one that we need to create is the graph of g of x, which is -6, -3, -4, 0, -2, 1, 0, 0, and 2, -3. And this completes the graph of g of x. If we connect the points, we're going to get this parabola that opens downward. So this is my g of x. Next, we need to describe how the graph of g is related to the graph of f. So I'm going to write the description up here. As usual, we're going to start by saying that the graph of g of x is the graph of f of x, but the first transformation was that it was shifted to the left, right? So we're going to say shifted 2 units to the left, or to the left 2 units, comma. Then the second one in pink, it says reflected over or about the x-axis, comma. And now finally we're going to say and the final transformation was that it was shifted 1 unit up or upward. And this basically completes my description. Next question. We are going to do the same thing on this problem. We are going to use the graph of f of x equals x cubed to create the graph of h of x equals 1/4 x cubed plus 5. So the first thing is that we're going to start with the graph of f of x as usual. So for you to be able to see this graph a little bit better, because we got a fraction, I'm going to make this graph a little bit larger, so you can actually see it better once we graph it. So we're going to start with the f of x equals x cubed. That's the first function that we need to begin with. So right here, f of x is equal to x cubed. That is my function. And for x cubed, just as usual, we're going to use the usual points that we usually use, which is -2, -1, 0, +1, and +2 as usual. So this one is x cubed, so if I substitute every x, -2 cubed gives me -8 as an answer here. -1 cubed is going to give me a -1. 0 cubed is going to give me a 0 as an answer. 1 cubed is going to give me a 1, and 2 cubed is going to give me an 8. I'm using 5 points again, just like I showed you before, because if you're not familiar with the shape or you forget, 5 points is always going to give you a better estimate of the graph if you're not familiar with the shape. So then we're going to start by, of course, for the function f of x equals x cubed, the first point that we got is -2, comma, -8, -1, comma, -1, 0, comma, 0, 1, comma, 1, and 2, comma, 8. Alright, so I'm going to graph that one just to have it already here. So -2, -8 is here. -1, -1, 0, 0, 1, 1, and 2, +8. And this is going to be the graph of the function f of x. Remember, it's going to be a little bit slanted right here, and then it's going to slant more, and then it's going to go slightly slanting as it goes this way. So it is this shape right here. This is the graph of f of x equals x cubed. Now, to create the function h of x, there are two transformations we have to do. The only thing to keep in mind is that this transformation, which is a +5, has always to be my last transformation. Remember, that is called a vertical shift, right? So that is the last transformation. So we're going to start with the 1/4. First thing I am going to apply is the 1/4 to the x cubed. What is that 4 going to cause? Remember that it causes that number in front of the x, it is multiplying. So it can have two effects. One effect is that it is going to either stretch the graph vertically up or shrink the graph vertically. So if, and according to the definition, if the number that is being multiplied is between 0 and 1, it creates a vertical shrink. And for the vertical shrink, all you have to do is you are going to multiply all of the y values for these points. You're going to multiply them by that 1/4. That's all we have to do. Multiply the y values by 1/4. And let's see what points we're going to get. So if I multiply the y values by 1/4, we get -2, comma, -8 times 1 is -8 over 4 is -2. -1, comma, then -1 times 1 is -1 over 4 is -1/4. I am going to write it as a decimal, -0.25. The next one, 0, comma, 0 times 1/4, that one stays the same, that one is still 0. 1, comma, 1 times 1/4 is 1/4, which is 0.25 again. And the last one, 2, comma, 8 times 1/4 is 8 times 1 is 8. 8 over 4 is going to be 2. And these are the points that we get right here. So, next transformation. Now we are going to apply the last transformation, which is a +5 on the outside. And that will basically complete the function. So we already did the 1/4 x cubed. Now we're going to apply the +5, and that is going to create h of x already. So that +5 is going to shift the function up 5 units, and what is the effect that it has on the points? All the values of y will be added 5 units. So if I add the 5 to all the y values on these points, then we're going to get the points -2, comma, -2 plus 5 is +3. Next point, -1, comma, then -0.25 plus 5, it would be 4.75. Then 0, comma, 0 plus 5 is going to give me a 5. 1, comma, 0.25 plus 5 is 5.25. And the last one is 2, comma, 5 plus 2 is going to be a 7. And if we graph these points, -2, comma, 3 is going to be up here. -1, 4.75, it's close to 5, so we're going to put it here. 0.5 is here. 1 and 5.25, it's a little bit larger than 5, somewhere in here. And the last point is 2 and 7, which is going to be up here. And if we connect these points, this is what the vertical shrink basically looks like. The original points were shrunk vertically. So this is a graph of h of x. to complete this problem, what we need to do next is that we need to describe. Okay, we're going to describe how the graph of G is related to the graph of F, how they're related. So I'm going to write the description here. So on the description, we're going to start by saying the graph of h of x, in this case is also h of x, is the graph of f of x, but the first thing that happened is that it was shrunk vertically. That was the first thing, but shrunk vertically. And when you do the vertical stretch or shrink, you have to complete the sentence with this. You have to say shrunk vertically by a factor of 1/4, which means by multiplying the y values by 4, right? Comma, and the second transformation was that it was shifted 5 units up or upward. And that completes this problem. Okay. Now, next problem, question number 18. This one is a very simple question. This one says, we're going to graph the equation in the rectangular coordinate system. Let's keep in mind some definitions. Anytime I have an equation that I want to graph in the form of x equals to a constant c, that basically creates what is called a vertical line at intersecting the x-axis at that number c. That's what the x equals to c will actually look like according to the definition. Okay, so in this case it is x equals to 4, so that will be a vertical line intersecting the x-axis at x equals to 4. So we're just going to create a vertical line from here all the way down, of course located at x equals to 4. That will be the graph of that equation, x equals 4. And the last question on this review is going to be the same thing. We're going to graph the function, the equation y equals to -5 in the rectangular coordinate system below. And this is another definition that you need to keep in mind. Anytime we have an equation in the form of y equals to c, a constant c, just a number, that basically is going to create a horizontal line intersecting the y-axis at that number c. That's what the y equals to c basically look like. A horizontal line intersecting the y-axis at y equals to c. So this one, if we go to this one is y equals -5. So that one is going to be a horizontal line intersecting the y-axis down here at y equals to -5. And that completes this question. That would be the end of this review.